Good afternoon, everyone. I'm Eddie Allison, a professor in the School of Marine and Environmental Affairs, and an affiliate professor here in SAFS. I've got the honor to introduce this week's Bevan speaker in this very well-attended and successful series with the theme Fishing in a Changing Climate. Thank you to the Bevan sponsors and to loyal attendees of the series for your continued support. I know a lot of you have been coming every week. Our speaker this week is Dr. Christina Hicks, Assistant Professor in the Political Ecology Group at the University of Lancaster's Environment Centre, and that's Lancaster, England, rather than Lancaster, Pennsylvania. She's an environmental social scientist interested in the relationships between the relationships that individuals and societies form with nature. She gained her PhD in 2013 from the Australian Research Council's Centre of Excellence in Coral Reef Research at James Cook University in Townsville. She then went on to hold an early career social science fellowship at the Centre for Ocean Solutions at Stanford University. And I've been fortunate to meet with and work with Christina at all three of those institutes. And I also remember you speaking actually at a conference when you were still a PhD student on ecosystem services and fisheries in East Africa, which is where much of her fieldwork is, the Western Indian Ocean and East Africa. So she's really worked across most of the globe, I guess. What else was I going to say here? Sorry. You know, because of our long association, it's a real pleasure to welcome you to Seattle and to UW. And I know that you've got existing collaborative research networks here on well-being, social well-being indicators, a group of people who've been developing those. And I gather you were field testing them yesterday while out sailing in Chilchol Bay. You've earned that time off, I think, because it's only mid-February and Christina has already published 4 papers this year. One in ecological economics that points out that ecosystem service valuation methods tend to emphasize the simple goods and services that accrue to individuals, such as the value of commercial fisheries. But they underemphasize the sort of complex social goods, things like contributions to social cohesion and well-being from having publicly accessible shorelines. So those more complex ones get neglected. And another paper published in Nature Climate Change, again this year, develops a new heuristic model of the coastal human population's capacity to adapt to climate change. Having the sort of material assets to adapt is often assumed to reflect a person's capacity. But the model develops concepts like flexibility and learning and organization and agency that provide a fuller, more useful conceptualization of this notion of adaptive capacity. And this new framework is going to be used to guide adaptation investments and funding allocation in tropical coastal waters. And in fact, it's already doing that in the UN Food and Agriculture Organization. So I think those 2 pieces of work really illustrate 2 prominent characteristics of Christina's work. First, there's that deep engagement with theory and methodology. And second, there's the application of that theory to inform and improve contemporary resource management. And I think a third characteristic that you'll see shortly in the presentation is that her work is very strongly grounded in empirical analysis, whether from global databases or localized case studies. And what I find particularly impressive about Christina's work is that she not only uses a larger methodological toolbox than most of us, but she's also really quick to see the inadequacies of existing tools and goes about finding ways of designing better ones. And the 2 papers I mentioned being just 2 of the latest examples. So Christina the scientist is a boundary-spanning researcher with a big toolbox who refuses disciplinary labels. She's also something of a transgressive force in the rest of her life as well. Born into 2 cultures and societies, the UK and East Africa, she confronts the legacies of colonialism in her work. She's active in diversity and inclusion initiatives in UK higher education. She's also her college representative for women's inclusion in STEM education. Some of the social activism inspiration came from her mother. The African side of her family came from the slopes of Mount Elgon, a volcano on the Kenya-Uganda border, roughly the same size as our own Mount Rainier. Her mother was one of 35 children, and unusually for a rural African woman of her generation, went through primary, secondary, and I think tertiary education as well. It was unusual for girls to be educated to that level at that time, particularly for rural families. And so Christina has really built on her mother's achievements and example. And when you talk to Christina's colleagues, as I have done, words like role model and inspiration sort of come up frequently. Her commitment to African development is unwavering, and her work there on fisheries and nutrition has just been awarded an advanced fellowship from the European Research Council of over €1.5 million, probably the most prestigious individual fellowship award in Europe. She's also just been awarded the Lancaster University Faculty of Science Early Career Researcher of the Year. So I guess you're having a good year, Christina. And the last time, finally, that I saw Christina, I think I'd arrived in Lancaster for a work collaboration, and that very evening she'd broken her foot while out trail running. And the only way this slowed her down during that week was all the extra time she had to take to stop and explain what had happened to every well-wisher on the Lancaster University campus, which I think was just about everybody. So she somehow had time for everyone, and in that week continued to organize meetings, write papers, participate fully in family life, all the while looking after me and ensuring that I had a productive and enjoyable visit. And also she looked upon having to get around on crutches as the opportunity for an upper body workout. So that tells you, I think, a lot about Christina. She sees the positive side of things, doesn't give up easily in the face of setbacks, makes time for everybody. She doesn't just talk inclusion and social well-being, she lives it. So in summary, what younger Americans might, she is what younger Americans might call a total badass. So Christina, hopefully you spent enough time in Stanford to understand that that's a compliment. And so Dr. Christina Badass Hicks is now going to guide us towards socially and nutritionally sensitive fisheries.
Thank you, Eddie. Gosh, that's a lot to live up to. I'm struggling to put my mic on. Thank you very much for inviting me here. It's really great to be back in Seattle. During my postdoc at Stanford, Phil Levin and Sarah Brestow invited me to be part of a working group, as Eddie mentioned, developing social indicators of human well-being. And Sarah and others have published a number of papers on well-being out of that working group. And a lot of the thinking that we did in those meetings have really informed some of the stuff that I'm going to talk about today. I led one of the papers out of this working group, and it was sort of a collective effort to try and communicate some of the really core social concepts that fisheries management, but also sustainability more broadly, really needs to engage in, but often struggles to engage in. And we went a step further and tried to suggest that actually some of these core concepts like power and agency and values can be quantified, which is a tension that I think social scientists really struggle with. The need to measure something so that it's not forgotten, but also the desire to resist reducing things down to something so simple as a simple metric. Anyway, after this long drawn-out process, we thought we'd eloquently communicated our ideas, and the editors at Science decided that they wanted to commission their artists to come up with an image to represent this piece that we'd produced. And I'll hopefully do this the right way. And this is what they produced. I was like, gosh, is that what we've just communicated? That social scientists stand in white coats with clipboards looking down and measuring society. So, I don't know, luckily they had a second iteration and we were a lot happier with this one. But I think it really communicates this tension we have, or this how difficult it is to communicate across disciplines, how you may think that you're actually communicating and translating, but the message, the core message, might actually get lost along the way. But I do think the climate is changing, and I do think social science is informing a lot more of fishery science and sustainability science. And I think science publishing a paper like this is really indicative of that. So it's really great to be here talking today at this seminar series on a changing climate in sustainable fisheries. So I'd like to take you back a little bit. I entered fisheries, probably like many people, measuring how much fish was coming out of the water, measuring how people were catching that fish, how many people were fishing, and what size the types of fish were. So this, as Eddie mentioned, was mostly along the east coast of Africa. And I did this firstly because I wanted to keep fishermen fishing. I firmly believed that there was enough in the oceans to sustain coastal communities. But I also did it because we believe that the primary driver of fisheries decline is fishing. So this model has informed a lot of the way we understand ecosystem change. So we understand these proximate drivers, such as fishing, but there are also a range of other proximate drivers like pollution, climate change, habitat destruction, invasive species, and they act on an ecosystem and result in change. There's been a lot of work documenting that this is the case. Nick Graham's done a lot of work in Seychelles, and what he's documented there is really compelling evidence of a fundamental regime shift. So in 1994, the reefs in Seychelles were dominated by corals, as you can see by that photograph up there. There was a climate event in 98, the big El Nino event, and in 2005, when they returned, the reefs looked very different, but there was still a lot of structure, so they weren't convinced that the reefs had changed. But by 2011, what had previously been these beautiful coral-dominated reefs were reduced down to these algal rubbles, and that was caused by the proximate driver of climate change. But increasingly, there's this growing realization that it's not just proximate drivers that act on ecosystems, but there's a range of distal drivers that act on these proximate drivers to bring about, ultimately, this ecosystem change. So this is a framework initially developed by Eric Lambin, but further developed by people like Jack Kittinger, that kind of proposes a set of 5 distal drivers that act on these proximate drivers to bring about the change. What we wanted to do was we wanted to test out this theory and see, does it hold? Can we identify a set of distal drivers that act on the proximate driver to bring about change? So to do that, we went to the literature, and what we were looking for was some of the most iconic examples of marine regime shifts. So I'm sure many of you will recognize these. And so we defined iconic based on number of citations. So where a regime shift had been documented in the literature and that had received a lot of sites. So for example, there's the collapse of the sea otter fishery on the US West Coast. There's the collapse of the cod stocks. There's in Jamaica, there was a regime shift from coral-dominated coral reefs in Jamaica down to algal beds, and then lastly in Chesapeake Bay through eutrophication. Now all of these, the initial papers, so Jack Estes, Terry Hughes, Frank and Kemp, documented these regime shifts, and they also identified what the proximate drivers were. So often overfishing, but also it was pollution. So I'm just going to run through a couple of these examples, and then I'm going to run through the process that we went through to try and understand them a bit better. So in the US West Coast with the sea otter fisheries, where sea otters used to live amongst these wonderful kelp forests. And in the 1840s, there was this, essentially the sea otters got completely fished out from overfishing, and there was this transition from the kelp forests across to these urchin barrens. In Jamaica, a similar story, but that unfolded over a longer time period. You had these coral reefs, coral-dominated coral reefs, and in 1980, Terry Hughes documented this regime shift from the coral-dominated state across to these algal blooms. So we knew from these papers that the driver of change was overfishing in the case of the sea otters, but also overfishing and pollution in the case of Jamaica. But what we wanted to do was take a few steps back and try and understand what was the context around the time when this overfishing and pollution was happening. What was driving the overfishing, what was driving the pollution. So we went to historical ecology, and so our colleague Jack Kittinger, who's written a book on historical ecology and has quite a lot of experience there, was working with us on this. And we went to the archives, we went to government records, we went to photo archives to really try and understand what else was happening in these 4 different case studies at the time. And if I talk you through just quickly the kelp forests in the US West Coast. So this is basically, we reconstructed these timelines, and you can see the legend there captures the 4 different distal drivers that we were looking at, so policy and institutional and governance factors. Then there were economies and market factors in blue, and then in purple, technological factors, and in brown is the demographic factors. So in the mid-1700s, Russia discovered sea otters and discovered that they could fish them out, and they made these wonderful gowns. They were fished out. The sea otter pelts were used to make luxurious gowns such as this one. And fairly soon after the sea otter fishery the sea otters were discovered by the Russians, a number of different markets opened up, so in quite quick succession. So the Russian trade began, then you had the British trade beginning, and then the American trade beginning. And a number of ships, expeditions would go out and fish out a lot of these sea otters. And partly because of the life history characteristics of sea otters that have a really slow turnover time, it was a relatively rapidly unfolding phase shift. So by the mid-1800s, the sea otters were completely fished out, and we'd seen this transition from kelp to urchin barren. After the mid-1800s, a few expeditions did go out trying to find sea otter pelts, and there was a couple of recordings where maybe they'd found maybe 10 pelts or so, and they were sold at exorbitant prices, but just really demonstrating that yes, the fishery had completely collapsed. So this was relatively simple in that there was one main driver acting to drive the overexploitation. It was this opening of this lucrative luxury export market. The Jamaican example was a little bit more complex, and it unfolded over a longer time period. So this one began in the 1500s when the Spanish colonial period in Jamaica began. And you had this long period of this slow drivers. You had slow population growth, and then this slow land use slow turnover in land use practices. So pigs and cattle were introduced, sugar and coffee plantations, and agricultural intensification. And it wasn't really until last century that the effect of the driver started really ramping up. And this was with the opening of, again, another market, and this was the tourist market in Jamaica, but also, probably catastrophically, some ill-informed fisheries policies just preceding the regime shift just in 1990s. So in this case, we had a slow, long driver acting, and then a faster policy and tourist market that was actually driving the overexploitation and the regime shift. So these 4 case studies, all of them had these well-documented distal drivers that resulted in the change. But in all instances, we identified, the proximate drivers were all identified, but for all of the 4 case studies, we identified these distal drivers that actually acted either individually or in concert to bring about this change. So what does this mean for management? So I guess one of the things that we were suggesting in the paper and thinking through when we were doing this was that often in trying to understand a regime shift, which is a fundamental change in the ecosystem structure and function, we look for these early warning indicators, which is often things like rising variance. And that's an indicator that an ecosystem is about to shift. But actually, once you're detecting that, and once you're that close to a regime shift, it's very difficult for managers to intervene, and because it's very difficult to stop an unfolding regime shift once it's started. And what we're suggesting is that if we can understand these distal drivers, and if we can better monitor them and their influences on the proximate drivers, then we're actually going to buy ourselves time. So we're going to have this far earlier warning, this far earlier indicator of impending regime shift. And this buys managers time to act and prevent an undesirable change. So we need to understand and we need to anticipate what drives fishing beyond just understanding that fishing drives ecosystem collapse. From a management perspective, we can monitor, firstly, for rapid escalations in the proximate drivers. So if the rate of fishing suddenly increases, or the efficiency increases for some reason, that's an indication that something's happening. But we can also monitor these categories of distal drivers. And it's also important to recognize vulnerabilities in the system. So with the sea otter example, the reason that phase shift unfolded so fast was because of the slow life history characteristic. So there's fairly compelling evidence that there are these macro-social drivers that influence ecosystems, that bring about ecosystem change. But as Eddie mentioned, most of my work is empirical. So what I'd like to think about, or what I do like to think about, is how does this then translate down to the ground? What are the microsocial processes? What is the relevance of this for microsocial processes? So, as Eddie mentioned, most of my work is in Africa, a lot of it in the east coast of Africa, or tropical coastal communities more generally. I suppose I do a lot of work in the Pacific. And these fisheries are characterized as being multi-species, so many different species are landed, and multi-gear. So fishers use a number of different types of gears, but generally they're pretty low technology gears. So it's relatively easy to enter a fishery. It's fairly easy to construct a spear gun, a hand line, and a little bit more investment to have a net. They're also characterized by providing food for communities that have a high level of dependence on the fishery. So these different photographs all are taken from landing sites in East Africa. And you've got various scenes of different people waiting for essentially the fishers to return with the catch and for that to be sold locally within the community. So managing fisheries in this context is complex, but it's also fairly pertinent. When we think about fisheries, we often think about the food, fish contributions, the nutritional contributions, or the income contributions that people gain from fisheries. We think a lot about the income contributions, and it's right that we do because people need money to live well. But they don't only need money to live well, and there's a range of other reasons why people go fishing. And when people live by the coast and they interact with the marine environment, they develop their identities and their sense of self are wrapped up in the environments within which they live. The other problem that focusing on the earnings that people get from fisheries does is it creates this simplistic mental model in which people benefit from the environment and they impact the environment. And focusing on the earnings that people get also defines a fishery by those earnings, so creating this race to the bottom. So if we're focusing on how much money people can get out of a fishery, then people will seek to get more and more and more money out of that fishery. So increasingly, when I do work in the context in which I work, I start off by asking people what are the range of contributions that they gain from the environment? What is it that why is it they go fishing? And what are the meanings and the identities and the benefits? What are the nature's contributions that they get? And I've done this through a process, a methodology called photo voice, which is essentially working with cameras and asking people to take cameras of things that represent the concepts and ideas that they're trying to communicate. And these photographs have all been taken by fishers, mostly in Kenya. And yes, food, income, and nutrition does feature prominently as something that's very important that they get from their fisheries. But there's also other contributions. So people's sense of self and their sense of identity is also a really important aspect of why they go fishing and who they are, as well as the various social and spiritual relations that going fishing and being by the sea provides to people. So rather than focusing on the earnings that people get from the fisheries, I like to ask about the multiple benefits and multiple contributions that people get. But it's not only important to think about the multiple benefits and the multiple contributions that people get. It's also important to try and understand how people are able to benefit, because everyone's different and everyone has different capabilities. This is a photograph of Amartya Sen, who won a Nobel Prize in economics for his work. And some of the work that he's most famous for is his work on famine. And one of the things that he noticed, or one of his statements, is that starvation is about people not having enough food rather than there not being enough food. And it might seem like a subtle distinction, but he came to this realization after living through the Bengal famine. And what he saw was that actually people were starving when there was sufficient food. And so it's not the fact that there wasn't food that was causing people to starve, but they didn't have access to that food. So it was either because the government was stopping them accessing the food stores, or there are other various social mechanisms that influences who can get access to what. So within a fishery, and within the context in which I work, it's important to try and understand how are people able to benefit from the marine environment and in what ways. To do this, I've drawn on a theory of access from Rabu and Peluso, who've categorized the ways in which people are able to benefit from the environment into these 9 different access mechanisms. So they start off with rights-based access, which we often think about. So for example, in a fishery, often people need a license in order to go fishing. So without the right to fish, you can't benefit from a fishery. Then there's a range of economic, market and technological mechanisms that enable people to benefit. So for example, if you live in a community with good access to a market, you're going to be able to get more money from selling your fish. Knowledge is another key mechanism they identified. So knowing how to fish, knowing where various fish stocks are, will influence your ability to benefit. And finally, there's a range of social mechanisms. So here I've just highlighted social relations. So in many of the contexts in which I work, certain people aren't allowed to go fishing. So women often are bad luck and aren't allowed to go fishing, but they're engaged in other aspects of a fishery. In Papua New Guinea, there are tenure systems and tenure rights, so certain people aren't allowed to fish in certain areas. So I've used this framework and I've applied it to a range of different countries across the Western Indian Ocean, so Kenya, Tanzania, Madagascar and Seychelles. And what I've been interested in trying to understand is how do people prioritize these contributions that they've identified as important from the marine environment? And what are the access mechanisms that they are able to draw on? And how do those access mechanisms influence their ability to prioritize or their perceived benefits from the marine environment? So I've done a series of interviews and focus groups with stakeholders, mainly fishers, but also community members, traders from over 20 communities across 4 countries in the Western Indian Ocean. And what I'd like to highlight here, so this is data that's been summarized across 4 different countries. But one of the key messages that came across is people cluster, or you can people tend to, you can cluster people according to the ways they prioritize different benefits. So people, down the left-hand side there, you can see the different types of benefits that we were looking at and interested in. And people tended to either prioritize, at the bottom there, these provisioning benefits, so materials and the fishery that they get from the ocean, from the marine environment, or they prioritize more these cultural benefits, so education and culture and bequest, or they have prioritized habitat benefits, or these regulating and supporting benefits like coastal protection and the the sanitation service that they got from the marine environment. So, different people have different priorities, which perhaps isn't surprising. But these priorities are mediated by their ability to draw on these different access mechanisms. So there are various social and cultural mechanisms that mediated access to the largest number of benefits. So by social and cultural mechanisms, we looked at levels of trust, levels of participation in the fishery, people's identity, how attached they were to a place, and whether they came from a fishing family. But there are also these economic and knowledge mechanisms that allowed them that mediated their ability to benefit from different contributions. Interestingly, the policy mechanisms, the rights-based access mechanisms that we often think about, didn't really feature as mediating people's perceived benefits. So the relevance of this is that, firstly, people benefit in different ways. But the way that they benefit is shaped by a range of social and cultural relationships, but also knowledge and economic mechanisms. So we need to, at this micro-social, at a community scale, it's important to better understand how people negotiate access. In the context of the Western Indian Ocean, it was the social and cultural relations that were most important in mediating access to the largest number of benefits, but knowledge and economics was still important. And context was also important. So when we look down at the different communities and the different countries, the same access mechanism could allow somebody to benefit in one country, but actually it created the complete opposite response in another country. So one of the key contributions that people identified in the context in which I've worked, so mostly in East Africa, from fisheries, is the nutritional benefits. And so I'd like to take a little bit of time now to talk about that aspect of the fishery. So in much of Africa, in coastal Africa, there are high, there's a high, in many coastal communities across East Africa, there's high rates of fishery consumption. Although people actually per capita eat half the amount that they do here in the US or in Europe, the importance of that fish to their diets is twice as important here. So the proportion of their animal protein that comes from fish is twice as much in the context in which I'm working than it is here, even though they eat half the amount of fish. It's also an area where micronutrient deficiencies are particularly prevalent. So this map here is just basically, the red is showing you areas where micronutrient deficiencies, so deficiencies in things like zinc and iron and vitamin A, are particularly high. So the reds are over 40% of the population of micronutrient deficient. We also know that fisheries in these areas are likely to decline. So that map over there is showing you where fisheries are likely to, fish catches are likely to decline and where they're likely to increase. So in red, in many parts of Africa, we're seeing a decline. We're going to see declines in fish catch. And together, this creates this perfect storm that Eddie and colleagues have written about in Nature a couple of years ago, where you can see here the countries in orange are the countries where they are going to be micronutrient deficient. They're going to be most vulnerable to losses in fish catch. So this paints a pretty dire picture. So the place that I love and call home, the fisheries that I've been working on all my lives, people are micronutrient deficient and it's going to get worse. But I do like to try and be an optimist. And when I first started thinking about these fisheries nutrition was when Eddie and a colleague of his, Dave Mills, came to talk about the work that they were doing in World Fish. And this was during my PhD. And Eddie talked about a lot of the work that he'd been doing at World Fish with other people in identifying pockets of local knowledge in terms of what types of species and what types of practices are actually particularly nutritionally important. And Dave, his colleague, talked about his work in Ghana, where the fisheries were really struggling, but he'd been working with these areas, and he talked about them as these islands of hope in a sea of failure, and how these islands of hope could seed successes elsewhere. So I caught onto these two ideas because I thought, they both were very compelling. And I guess the question then that I want to ask with this kind of approach is there the potential for marine fisheries to meet nutritional needs in these contexts where fisheries are declining, deficiencies are high? And so I'm just going to put up a heuristic here, which tries to represent my thinking. So along the y-axis there, we've got nutritional yield. If we can understand what the fisheries nutritional yields are, and if we can plot that against prevalence of nutritional deficiencies. In places where the nutritional yield is low and deficiencies are low, there is not likely to be the potential for fisheries to meet nutritional needs, but it doesn't matter because the nutritional needs are being met by other sources. Where nutritional yields in fisheries are still low, but there are high prevalence of deficiencies, still, fisheries are not going to be able to meet these nutritional needs, but we need to turn to alternatives. Where you have areas where the nutritional yield in the fisheries are high, but deficiencies are low, yes, fisheries have the potential to meet nutritional needs there, but it's probably not that important. And it's this final quadrant that I'm interested in looking at and trying to find out what are these places that fall in these areas where there are high nutritional yields, there's a large number of nutrient-rich species being landed, but prevalence of deficiencies are really high. And these are the islands of hope that I'm hoping that we can find. And in these islands of hope is where we can hopefully begin to start asking what are the social drivers of exploitation and what is it that mediates access, so that we can hopefully shift these islands of, identify these islands of hope and meet people's nutritional needs there. But here, so we know that fish are high in micronutrients. They're high in a range of different nutrients, such as omega-3, that's important in this part of the world because it helps control coronary heart disease. But they're also high in a range of other micronutrients, so vitamins A, zinc, iron. They're particularly prevalent in low-income countries. And we eat, in the West, 4 to 5 different species. So we've got a pretty good handle on the nutritional content of the species that we eat. But in the context in which I work, many of the coastal countries in the tropics, people routinely land hundreds of different species. They're different sizes, they live in different habitats, and we don't have a good understanding of what the nutritional content is of these different species. So a key question is, what micronutrients are available in the nearly 1,000 different species that people across the tropics eat? So to begin to answer this question, what we wanted to do is we went to Web of Science, we went to FAO InFoods database, and we went to experts in nutrition to try and ask them, what do we know, to gather the evidence that we know about what species contain what types of nutrients. And we collected this database, and there's quite a lot of information. So we put together a database of 14 different nutrients and over 400 different species and over 4,000 different measures. Just to give you an idea of the types of values, so the average nutritional content of 4 different nutrients, zinc, calcium, iron, and vitamin A, were all in the range of the recommended daily amounts. And they're all comparable with food substances like beef, which isn't surprising. But if you look at the numbers in the red, the variability across the different types of species was huge. So some species have next to no nutritional content in them. Others have way, way, way more than what a child and mother or an adult would need in a day. The other thing that was noticeable about this database was it came from a large number of different countries. So this map shows where the data we collected comes from. So it came from 45 different countries, but It was notably absent from the countries in the tropics where we're most interested in, where we don't know what the nutritional content in the species. So we do have pretty good information on nutrient content. We've got pretty good species representation in terms of which species have what in them. But there's a lot of variation across across species, and the data is geographically patchy. But there is quite a lot we can do with this data. So what we do know that the nutrients in a fish is going to be influenced by what they eat, it's going to be influenced by where they live, and it's going to be influenced by its energetic demand. So we developed a Bayesian model to try and predict the nutrient content in the species for which we don't have data for. And I'm just going to quickly run through the results of that for you. So the first column I'm bringing up here is for protein. And the thing that I'm just going to highlight, and this, so all you need to take away from this, really, I'm sure many of you know how to read these results. But essentially, where you've got a solid circle and it's black, it's a significant effect. If it's to the right of the line, it's a positive effect. If it's to the left of the line, it's a negative effect. If the circle is hollow, it's crossing the naught line, the zero line, then it's not a significant effect. So for protein, species that have a pelagic feeding pathway and that have higher trophic levels tend to be higher in protein content. But the effect size is pretty small. So yes, it's significant, but it doesn't have a very big effect on the protein content of a fish. So when it comes to protein, a fish is pretty much a fish. Oops, sorry. But if we look at the other nutrients, so zinc, iron, and calcium, which are the nutrients that are most important in the low-income countries of the tropics, which represent these micronutrient deficiencies. So you may not think of a fish as a source of calcium, but in communities where, in places where people don't drink milk, then fish can be a really vital source of calcium, and there are really high rates of calcium deficiencies. And so what we find with these nutrients is that species that are found in a tropical thermal regime and species that are smaller tend to have higher concentrations of zinc, iron, and calcium. Sorry. And the last thing I'll just show you is omega-3. So that is of interest to people living in the West because omega-3 helps combat coronary heart disease. And what we know is that species that have a pelagic feeding pathways and that are found in these colder thermal regimes tend to have higher omega-3. And we know that from, the studies that have found that in populations in the Arctic, low rates of coronary heart disease. So we know that protein, so based on this model, so protein, there's relatively small variation across different species in terms of protein. But with calcium, zinc, and iron, we know that smaller species tend to have higher concentrations of these nutrients and species that tend to be found in tropical thermal regimes. And with omega-3s, they're higher in species with the pelagic feeding pathways that are found in a polar thermal regime. So having filled in the gaps, we can then apply this model to what we know about what's being caught in countries' economic exclusive zones to try and identify what the nutritional yields are within fisheries. I'm just going to run through a couple of the maps here. So just to remind you where we have high rates of nutritional deficiencies. And on this side, we've got catches in EEZs. This map on the left-hand side is the zinc yield within a fishery, within countries' EEZs, and iron yields within countries' EEZs. So unsurprisingly, zinc and iron show fairly similar patterns. And there are hotspots where we have really high iron and zinc concentrations, often in these countries in the tropics, which are also the countries where you have those high rates of deficiencies. With calcium and omega-3, you can see these high rates of omega-3 in the high latitude countries. So there are nutritional hotspots. So areas, geographic areas where we've got rich in nutrients in areas of nutritional concern. So coming back to our islands of hope in a sea of failure, this suggests that there may be islands of hope. So the last thing I want to show you is if we plot up nutritional yield, so what's in those landings in the EEZ, against patterns of nutritional deficiencies. And for this, I'm just showing you iron. Up the y-axis, what you're going to see is based on a country's iron requirements for the coastal population for under 5-year-olds. We calculated the extent to which the iron yield in the fishery exceeds the demands of that coastal population. And what was found was actually a large number of countries fell in this top right-hand quadrant, where their landings, the landings coming out of their EEZs, exceeded the nutritional yields for the coastal populations, despite being in an area where the prevalence of anemia was particularly high. So the cutoff point here is 20%. So examples, countries were like Mauritania. Mauritania would need to retain 3% of their landings in order to meet the coastal band's nutritional yield. For Malaysia, it would be 35%, and Egypt, it would be 9%. And just plotting up the countries that came up top in the list with the highest rates of deficiencies, so over 70% prevalence of anemia in the countries, and the proportion of their catch that needed to be retained in order to meet the coastal band's nutritional needs. And so this finding isn't necessarily alarming. A number of people have written about perspectives that fishers in the Pacific have been saying, and coming out with quotes like, "We see them taking our fish and we get nothing in return." So what we seem to have is this situation where we have a large number of countries where there's high rates of malnourishment swimming in this sea of nutrients. So rather than these islands of hope in a sea of failure, perhaps what we've got is these islands of failure in a sea of hope. And I think that can be that's a more optimistic situation, because there's a lot more that we can actually do with that. And I think it's in these instances where we need to ask these questions. What are the social drivers of exploitation? Is it trade policies? Or is it international markets that are driving exploitation of these fisheries? And why is it that the landings that are being fished out of the EEZs are not being consumed locally? Is it to do with technology? Is it to do with diets? Is it power dynamics? Or is it lack of access to capital? So just summing all of that up, I guess the key messages that I'd like to make from this talk is, firstly, we need to establish the potential contributions and limitations of fisheries. So when can fisheries meet people's needs, make those contributions that people want? And there are multiple contributions. So I talked about nutrition in the last example, but it could be identity, it could be culture, and it could be well-being. Having understood the potential contributions and limitations, we can then try to understand and anticipate what it is that drives fishing. So is it these distal drivers that are acting outside of the system? Is it distant markets? Is it new technologies? Is it policies? Is it culture? Is it demography? And at this micro-social scale, micro-processes, how is it that people can actually access? How can they negotiate access to those contributions that they want? So these cross-scale mechanisms could be knowledge, social, economics, and rights or policies. And with that, I'd just like to say thank you. Obviously, I worked with a large number of wonderful collaborators. So all of this work has been influenced by, and obviously lots of other contributors have contributed to this work. Number of different funding sources and data sources. And thank you for having me here today.
historical ecology, Bayesian estimation, photo voice, access regime analysis. I told you she had a big...
Good collaborators.
Questions for Christina?
Thank you, Christina. Yoshioda from SMEA. I sort of understand you appreciate fish as a social material. It has a value more than a food.
Yeah.
And I kind of understand your later talk, you appreciate fish as sort of a nutrition, which is countable. I still cannot really understand why you separate those two and count it. Perhaps you can explain a little bit more how you're going to sort of put it together, those two completely different set of values, if you call it.
Yeah, no, sure. I suppose I didn't intend to separate them. So I think when I was talking about the multiple contributions that fisheries make, social, cultural, but that did also include economic contributions and also nutritional contributions. And then I think in the last part, it was just really trying to drill down into this one dimension, so the nutritional contributions, because that's something that had really come out from working and looking at the different actually contributions, and that was the one that sort of rose to the surface as most salient, I think. But it's not to, but all of the other contributions still exist and are still important, and maybe more important in different contexts.
Right. Thank you.
Christina, you can take whoever you want.
Sorry.
So I wasn't surprised to see Mauritania pop up there as having still a little of that retained catch, right? I'm assuming that's mostly small sardines that are shipped up to Europe. And I guess my question there is, problem of allocation of fish or a problem of the allocation of the money that comes from selling the fish to Europeans?
So I think that's, I imagine that yes, the fish doesn't, I think you're right, the fish doesn't go there at all. And I think what you're saying is absolutely right. It's the problem, the money is what's driving the reallocation of the fish resources. It's too profitable to eat those nutrients in Mauritania, I guess, or somebody's making that decision that it's too profitable for that tiny proportion that would need to be retained in Mauritania. It's politically and economically, it's not worth. The decision's been made that it's more profitable for them to go elsewhere. Whether that's to do with a lack of technology for Mauritania to exploit it themselves, or whether it's to do with a legacy of licenses that have been issued out, I don't know. But I think that's the type of thing that I want to think about and dig into further. Yes.
In your picture of fish being caught, there were lots of little fish.
Yeah.
But in the market picture we saw, there were the big fish.
Yeah.
And I'm wondering if, in addition to the fish that are sold for money, if the people who can't afford, and perhaps the families of the fishermen, are eating the small fish, which you showed were nutritionally better. So I wonder if there's two different pathways. One is the market pathway, and the other is what happens to all the small fish that they may not have a market for, but perhaps gets distributed within their families or extended families.
Yeah, I think you're right. I do think there's a lot of potential for, a kind of win-win situation in which, yes, the big fish that tend to be high in protein, but it's an expensive source of protein, can be sold to the market or to elsewhere, and those small fish can be retained and eaten and cooked up in a soup.
And you showed they were more nutritious.
Yeah. I think, unfortunately, what happens is a lot of times, so firstly, there's been this process of, legislating away from catching small fish because of various, ecosystem dynamics. But then secondly, the small fish that are sold, that tend to be bought by the women traders, mama karangas, are fried in oil. And whilst that doesn't get rid of the nutrients in it, it kind of introduces an unhealthy aspect to people's diet. And they're sold sort of in the street. But I think, I think there's so many questions to be asked. And I do think there's lots of opportunities to meet nutritional needs while still actually gaining a decent earning. The other thing, actually, the market I showed you was Seychelles. So it's the wealthiest country in the region.
Does nutrient quality change throughout the life history of individuals' fish? And can we change our selectivity of those fish to maximize nutrient output?
I think that's a great question. And I think that's another thing that I think absolutely I think there's an awful lot that we don't know. That we particularly, we know, yes, we do know that smaller juvenile species tend to be more nutritious, and yes, it does change through their life history, but I think there's lots of questions that we can still ask, particularly because, in the Sea Around Us database, there's over 2,000 species that are being landed, and so there's a lot of information that we don't, there's, lots of questions to be asked. But I think, the idea about can we fish smarter, I think Zach probably can answer that. Yeah, give him a year.
Yeah, I think we've only just, in fishery science, only just begun to ask questions around nutrients. I think until a few years ago, people talked about fish as sources of protein, but the sort of analysis of micronutrients and the micronutrient content and importance of fish in that way is a more recent discussion in fishery science. So, question?
Yeah, so in your distal drivers, you have governance, policy, and institutions.
Yeah.
And then when you applied those to sort of your micro-level setting, you found that policy is not a significant driver of people's ability to access these various services.
Yeah.
This is surprising to me. And I wonder if you could say a little bit about how you operationalized policy, because what I saw there was really focusing on rights-based policies. And of course, the governance mechanisms in fisheries are a much broader set of mechanisms than just rights-based policies. Could you speak to that?
Yeah, so I guess, initially, I purposefully went to representative sampling of communities within each of the 4 countries that spanned the range of kind of broad fisheries management that happens in the region. So we went to areas with fairly strict gear restrictions, so mainly mesh size. Went to areas where there were complete no-take zones, and then we went to areas where really there was no really recognized or form of management, because I was expecting there to be I was expecting management to be what kind of drove the differences, and so I was really surprised that it came out as not having an effect. But I guess the important thing here is this is people's perceived benefits. So it doesn't mean that they're actually, their catch rates might be different, their levels of earnings will be different. It's just what the perceptions of what was important to them wasn't influenced by what management regime they were under, which I still think I found actually quite surprising.
Could that point to the fact that none of the management regimes was particularly effective, and that's why they didn't feel that it was important?
I think some of them are effective. Well, I guess effective, it depends what you mean by effective. I think, so you had co-management regimes, you had government-imposed regimes. It was a whole range of both kind of almost locally relevant or very locally informed versus kind of imposed, as well as gear and,
Any final questions?
Given your work on Malthusian overfishing and higher nutritional content of smaller fish, do you have any opinions on ideal management strategies in areas where there's that nutritional deficit?
So I think the whole, so I think where we, at least in the Malthusian work that we've done in Kenya, what we've seen, what happens where there's high rates of fishing, even where there is management, what it sort of does is it homogenizes the fishery. So we go from people catching many different species to just a handful of species, mostly herbivores. So I imagine, I'm guessing here, that actually that will have nutritional implications. Where, I guess, where you have, say, area-based management, it maintains a diversity of species, and in that instance, it actually, the trophic level of the whole catch increased. So likely, the protein content of the landings would have increased as well. But yeah, I think again, back to a question that was here, and I think what Zach's doing is we really need a better understanding of how various management regimes affect not just biomass and the trophic level, but also the nutritional content that fisheries are landing. There could be, could be good outcomes, could be not so good.
Watch out for an upcoming paper.
Yeah, yeah.
Not related to nutrition, surprisingly. So you said that variance was an indicator of proximate
Impending,
relationships?
yeah.
But what about the variant? Can you actually be able to sort of see through the noise in the distal mechanisms to tease apart whether or not they might be indicating a regime shift? Because it seems like the further back you go, the more the variance can be explained by an infinite amount of things outside of kelp to urchin variance transition.
Yeah. So I guess that variance thing that often is looked at, I guess, within sort of yeah. But I guess a couple of things that we said about that, if you see the rate at which exploitation is increasing suddenly shoot up, then that's an indication that a distal driver is acting on it, and it's worth investigating. So you've not reached the point of a regime shift, but you've suddenly sped along the kind of, you've increased the rate at which the kind of fishing pressure or fishing effort is you've intensified it quite rapidly. That could be from a new type of technology, so fish finders. It could be from opening a new market. It could, so that's one thing to look out for. So looking for that increasing intensification suddenly. But the other thing is, some of the distal drivers that we identified are these pulse effects. So it is important to monitor for things like markets. It is important to monitor for things like new technologies, because we know they will have a clear, noticeable effect. We don't know where along the curve of an impending regime shift you are, but we know we're moving in that direction.
Any final questions before we break for refreshments? If not, then thanks very much again, Christina.
Thank you.